And now, I formally invite our resource person, Dr. Sheval Mukherjee, sir, to begin with our first session of the day on the topic, Project-Based Learning in Entrepreneurship Case Studies. Sir, the stage is all yours now.
Thank you. Okay, that's okay. Up to you. Hi, good morning to everyone. Should I wait for the caller mic or I should start? Fine. Hello. Hello. Yeah, once again, good morning to everyone. Am I audible to the last in a row? Okay. So, first of all, many congratulations to my beautiful wife, Professor Pallavi Mukherjee, who is eventually the coordinator of this faculty development program, and many thanks to co-coordinator madam also, and of course, the person from whom we had been, starting, or we should not be saying that starting, we had been learning, that is our Kushwaha sir, Vivek Kushwaha sir, since 2013 when she joined as a faculty member of IBMR. So what we had been discussing also today morning in his office, that irrespective of whichever domain or whichever specializations we work in, we work professionally irrespective of academia or industry. The major thing that we actually learn from our peers is discipline. So thank you so much, sir, for actually telling us how disciplined way we can actually deal with many aspects of our lives. Like the examples that I have been telling him, like I kept on hearing, like sir is available early in the morning. Whenever you need something from him, you need to get some advice. Late nights also he is available. Weekends also he is available. Even if he is on a trip with his family to somewhere else, he is already available. So he is available for all of us. Even if I belong to a different institutions, in many ways also I keep on learning these things from him. So thank you so much, sir, for telling us what we should do to thrive in our life and to be successful in our lives. And now coming back to this particular faculty development program, because I belong to a domain of engineering, even though it is a Institute of Business Management and Research. So kindly raise your hands, how many are from the domain of science and engineering? Okay, thank you so much. So basically I have prepared this slide in such a way because some of the results of research and innovation I'll be sharing that we had been doing at IIT Indore since my joining to the institute in September 2010. So some of the scientific and engineering work we will share, and I will try my level best not to bore you, because too much discussing about the technical aspects, it make you feel bored. So some aspects in which, because we are engineers, like even though we do irrespective of the specialization doctor of philosophy, so once you do PhD, you become a philosopher, irrespective of you come from management or you come from economics or you come from science or engineering. But our core does not change. So my core is engineering. So engineering, the very aspect of it, you start with applications. 10 years before today, 2025, applications means publishing a paper. That is actually what sir has been stressing just before my speech also. Now applications we are trying to reach the commoners. Unless and until we reach commoners, we reach something for the nation or do something for the nation. Our applications, our patents, our journals, everything is basically a useless quantities, we should say. So we'll be starting also giving you some information about why we do innovate, why we do R&D, why we go for commoners, what commoners actually need. In many cases, commoners are actually all of us sitting inside this room in many different aspects, in many different domains and quality and quantity aspect wise. So the topic project-based learning in entrepreneurship case studies, I'll be giving you 3 different case studies in these cases. We'll be talking a domain of application, that is the sensor. And this sensor, nowadays we keep on hearing about the words, buzzwords are around, data science, AI, IoT, quantum communication, quantum, all those things. So today I'll be sharing about some aspects of quantum materials or quantum material based sensors, primarily oriented towards 3 aspects of it, applications. One is the sustainable agriculture, another is healthcare, and another is environment. Those aspects which as per SDGs are very, very important to each one of us. But before we actually start and move further, I would like to mention about the motto that my research group and our technology group has been working at IIT Indore. We call it Hybrid Nano Device Research Group, HNRG in short. So what we do is actually demarcate it in this, or actually expand it in this hexagonal mode. We start with working using our softwares. So first step in any cases, like if you go for a look something for the domain of semiconductor manufacturing, another, we should say dazzling word which have now become, very much prevalent in terms of the media or in terms of newspapers. But semiconductor manufacturing starts with modeling. So first you need to get the aspects what you need. If we look for the commerce, we ask what we need. Then a need comes to us, then we first design. If the design aspect is done, then we go for actually the fabrication part of it. The fabrication part of it goes for the material growth, then goes for the characterizations of it. Characterization means, like for example, if I say a person is taller, or if I say a person is smaller, or a person is very beautiful, so how do you quantify? So you quantify using your vision sensors that the God Almighty has given to you, our eyes, or you hear something from somebody else. So you need some sensor, vision sensor or hearing sensor. The same thing for characterizations for materials. How good are your materials? You do several aspects of it. You study how well it is connected chemically. You also study how does it look like. You also study how is it in terms of performance about various aspects of the materials like optical, electrical, mechanical, those aspects. So we call it material characterizations. Once you are happy, then you go for device processing and fabrication, making actually their own device. And once your single device is successful, you go for the system manufacturing. Then once your system manufacturing, after several studies of different aspects of it, then you go for the system development and commercialization. And for commercialization, you again come back to the research domain or the innovation domain. For example, iPhone 11, how many of you had? iPhone 12, iPhone 13, 15, 14, 16, how many of you had? So if we, for example, asking about iPhone, that is a part that we need. Who told us to buy it? Nobody told us. We just saw in the market, we just saw our colleagues to have it, we just saw in the media, then we keep on getting, for example, iPhone 15. Then iPhone 17 is released after 2 years. Again we need it. So that means once the system development is done, then again your greediness or your aspect of having more features enhances. Then you come back to research again. You again start doing development. So this hexagonal process goes on and on. Where is the end of this hexagon? Nowhere. Because the hexagonal pattern, whatever you are seeing, is actually your dream and imagination. If you are dead, you cannot dream anymore. So you are alive, you are dreaming. If you are dreaming, you are asking for something new. Who will be making for you? You only, nobody else. So it is basically standing in front of a mirror asking that I need this. So the mirror will be telling you, go and make this. Okay. So if you look for these aspects, so it is not only I belong to electrical engineering, I do electrical engineering. We need to have expertise from different domains, physics, chemistry, biology, mechanical engineering, so on and so forth. So nowadays, or not nowadays, I should be saying more than 10 years now, interdisciplinarity of subjects. We keep on hearing these words also. That becomes an aspect of today's semiconductor manufacturing. If you have a domain specialization, even in economics, we need that for semiconductor manufacturing. If you need management aspect of it, we need that. We need those expertise also for semiconductor manufacturing. Nobody can say semiconductor manufacturing is only for computer science and electrical engineering. So that's why we need to work together to build something for the country. So that is the very aspect of our research group, H Energy we call it. Now 5 different applications we think of. We work in the domain of solar cells, photo detectors, memory systems, high electron mobility transistors, and today's aspect is talking about sensors. Okay. But before we go, yes, the backbone of our whatever we do is our students. Our students are sitting just amongst yourselves, and many are actually also working in our lab, and many have also graduated. And the very heart of it, we should say heart and brain connected so that you can do something. So the heart is actually standing in middle, just next to me. She is standing right there. So because of her, we actually started this startup, whatever we call Quantech L2M Innovations Private Limited, and we'll be showing you like how we have started the journey and how actually we thought about bringing the products for the market. So before we wait, we need to acknowledge. So somehow I do not know why this scale is not shown properly. Do I need to do something so that the entire screen is shown? Or should I minimize the screen so that this aspect is shown? My full slide is not visible. Fantastic. I think the top portion. Fantastic. Thank you. Thank you so much. So many congratulations and acknowledgement to them, backbone of our group. And acknowledgement for these students coming from undergraduate domain, postgraduate domain, even PhD. The things, whatever you are seeing in the blue fonts, they are actually alumni of our group. And they are already doing very good in academia, in industry, in many different industries also. And the things which you are seeing in black in color, they are currently working students with us in different domains. And of course, whatever we do, we need to acknowledge our funders. We need to acknowledge our collaborators from not only within India, but across the entire world. Because whatever we do, it is 90% we should say, or we should say 80% experimental and 20% in terms of simulation and software oriented. So we need major flow of funds, and we are grateful to all of them. In many cases, we need to use very sophisticated instrumentation that unfortunately currently many institutions of our country do not have. For that, we need to actually are dependent of our collaborators. So many thanks to them. Now, coming to quantum scale, because you remember our talk is on quantum sensor, quantum scale. So some of the quantum aspect of it, like in our basic education in our schools, class 10, class 11, class 12, whenever we need to talk also, during my teaching of many courses in IIT Indore, we used to hear that things that is determined with respect to the spectral wavelength of light or frequency of light. So dependent on that, there are few things which are available in the mother nature. So that aspects are here, things existing in nature. And here what we are actually specifying, we are specifying about the dimension of it. Like for example, dust mite ant of the order of millimeter. We are talking about red blood corpuscles, we are talking about human here, we are talking about adenosine triphosphate. You remember adenosine triphosphate, broken adenosine diphosphate and phosphorus, and goes back and gives us energy so that we can work. We are talking about DNA, deoxyribonucleic acid, ribonucleic acid. So if we move from top to bottom, that exists in nature. So we are downscaling. Now things on your right hand side, this you are making. Who is asking you to make? Always remember, you are asking yourself to make. You know, starting from NAMES devices, you are going for nanotube transistor, you are going for quantum coral system, you are going for carbon nanotubes. Innovations, that has to be done at the lab, and the lab goes for the commercial. So this is our quantum scale. Okay, all of you, if you remember and recollect the information, classical Newtonian mechanics, then we go for quantum numbers. Now all of you remember, you know, whatever we have learned during our class 11 and class 12, we deal with all those things. Now we need to deal with the quantum mechanics aspect, because if we are downscaling it to get some better performance, we need to also study it. You remember the first step is device modeling. Unless you understand the things that is coming from your system, you will not be able to actually comprehend whatever features you will be getting back from the entire system that you develop based on those materials. Okay, so you study this. So what is quantum scale science and technology? Again, downscaling I am referring to. We are just reducing the dimension. You know, human here, I have mentioned few millimeters. You reduce down the dimension, you will not be able to see it. So here, the aspects you will not be able to see it. We are talking about nanometer. 10 raised to minus 9 of meter is 1 nanometer. We are today in the world, we are even talking further below of it. So once you minimize it, you basically cannot segregate that this is physics, this is electrical, this is chemistry, this is biology. No, you cannot aspect. You cannot segregate. Everything comes at the plate in front of you. You need to get to know everything. You need to have the people having expertise from all domain to study those aspects. How many of you know the name of this gentleman, Richard Feynman? Yes. So he is the one who actually ignited people to dream. That point of time, 1959, you can imagine, none of us at that time. Okay, so that time he dreamed about it. What if the dimension is reduced? He first thought about it and gave a lecture at Caltech in 1959. He is the father of nanotechnology. So whenever we used to talk about quantum or anything, nano, reducing of dimension, this is the father we need to mention. So he started, he dreamt in 1959, and today also we are dealing with all this. There is no end of it. Okay. So just to give you how big, actually in his talk he mentioned there is a plenty of room at the bottom. So even if your dimension is reduced to 1 nanometer, you remember our hair thickness is millimeter. You go downscale and go to 1 nanometer, he still said there is plenty of room even at 1 nanometer. So how big is it? So there is a beautiful video, I got it just to show you how big is this scale, even if you do for the downscaling. So you start with centimeter scale, go for the human hand, and slowly you keep on reducing or enhancing the magnification, reducing the dimension. And all those aspects you touch it, and those aspects are actually determining the product development that humankind need. So the basic point remains the same. You need to keep on dreaming, you need to keep on imagining. Whatever you have today, you forget about it. That is what every aspect or every person sitting here will keep on doing things. So you need to dream. Now dream for what? Dream for yourself only. You talk about any industries. The industries which are also not mentioned over here. We keep on dreaming. What if we can get further and further? We talk about fashion, consumer electrics, automobiles, we talk about bullet trains, we talk about IT industry, telecom, whatever you think about, agriculture, healthcare, whatever you think about today, you keep on dreaming, what if I have that? Okay, so that's why the basic idea is what our Prime Minister has been stressing on, Viksit Bharat 2047 aspect, the mission. So the mission, the very core of it lies in the domain of innovation, lies in the domain of dreaming and imaginations. Okay, so few applications I'll be sharing with you now, and then slowly we'll be moving to our topic, so that you can understand how actually we are looking to get something which today is not existing. So I keep on telling this in my class also, this question. Is gold always gold? What do you mean by this? Whenever we think about gold, what comes in our mind? Glitter. It comes the aspect of this color, of course, right? If the color of the gold becomes something else, like pink, will you be interested to buy? Like for example, you go to Tanishq, for example, you go for some carat measurement, and in the same carat measurement, Tanishq is giving you beautiful necklace pink in color. Are you going to buy? But can gold become pink? Can gold become blue? How you can do? So basically we tick with the size of gold particles. You keep on tweaking their particle size, you keep on getting those kind of colors. But today you ask any person in the entire world, are you interested in gold? Yes, but you do not need to pay. Yes, very much I am interested. Are you interested to buy gold in that color? No. The answer comes in front from all of you. So this is telling us, by changing the dimension, by going towards what we had not been there in the bulk gold today, we have no use as of now if the gold changes color. But do we need something in which we are reducing the dimension and we need that for our own purpose? Like for example, I am sharing you another small clippings and I will be connecting why I am sharing this. So talking how it is connected to our nanometer world or quantum world. So something from outside cannot enter inside and something from inside cannot go outside. It is connected to this. We call it SPF, sun protection factor. So UVA or UVB emission should not come. We need sunlight for vitamin D production, very nice. But you also do not need UVA and UVB part of the solar radiation to irritate our skin. We do not need skin cancer. We do not want our moisture from our skin to go out. So बाहर से अंदर ना आ पाए, अंदर से बाहर न जा पाए. Okay? So now we are seeing the applications part of it. If we go downscaling for what? Fashion. Who has started working on this and it has become a $1 billion market as of now? Which company? Do you know this gentleman at the bottom of the screen? Anyone? He is the founder of L'Oreal. And he started commercializing this aspect of one of this compound. We are terming it as zinc oxide. There are many aspects of it, but ideally the material should absorb UVA and UVB emission. That is not good for us, but UVB is critically required for the production of vitamin D depending on the exposure time and irradiance values. So there are many aspects of it. You can work, tweak on the material properties. So huge market is there. So now color of the car, for example. We have talked about the color of gold. We have talked about what we need. Like, yes, we have seen people wearing this kind of, aspects of some kind of lotions and playing for cricket, or we have seen playing tennis. Like, what if, like many of us who go out in the sun, we use high values of SPF. That is good. But SPF, if you keep on increasing the values of this particular compound in the moisturizer, you will not be able to see it look pale. It will be looking white as they are wearing. So now you are going for a marriage party, birthday occasion. Would you actually like to see that your nose is becoming white? So you need like that. You will be wearing high value of SPF. It will also be transparent. But for gold, it was not permissible for you. But for SPF high value of cream, it is permissible. That I want the white should go out, but it's still like should be saying or sticking onto our cheek. So innovation, go on the miniaturizations. Okay. Any other aspect? Like for example, I was talking about car. Somebody likes, beautiful white car. Somebody likes black in car. There was a movie that was released in 1980s, Mr. India. How many of you have seen that movie? Suddenly you click something, you become invisible. Is it a reality? You change the color, the whole part of it. So IBM has made it. In 2022, they just showcased this product in which the car is actually changing the color by introducing E-Link technology. I'm sorry, BMW, not IBM. So at Las Vegas, they organized this consumer electrons show.
This is the world's first real color changing car. There's been fakes out there, there's been projection mapping, there's been light. This is really energy efficient color change using the technology E-Link. It's never been done before, so this is a proof of concept. My favorite use case is the use of color to influence sunlight reflection. So on a hot sunny day like today, you can switch the color white to reflect sunlight. On a cold day, you can switch it black to absorb the heat, support climate control, and support sustainability. And the awesome thing about this technology, it's bi-stable. So if you switch it white and take the power off, it stays white, so it doesn't need any energy to hold any given color.
So that's why people have not stopped. They kept on dreaming about it. Can you make a transparent car? Can they make it? Yes, they can make it. But can they put it on the road? Transparent car? No, not possible. But Mr. India today is possible. Okay. Now, coming back to our topic, sensors. World of sensors and arts. What kind of sensors we are talking about? The sensors that detects whatever wrong thing is going on in the environment, be it in water, be it in the atmosphere. We all know today what is happening in many, different metropolitan cities in the northern part of our country. We keep on hearing in the newspaper. We keep on reading those aspects. So we need the sensors to actually sense those and tell us what we need to do. In many cases, we need to actually go and clean manholes. In many cases, we need to do and go for the mining. So for those poisonous gases, sulfur-related gases, nitrogen-related VOCs, volatile organic compounds, or carbon-related, they are detrimental for people's health. So to diagnose those with perfect clarity and sensitivity, we need robust sensors. In healthcare, blood pressure, blood sugar, or maybe uric acid meter, or maybe creatinine sensing. So for those also we need sensors. we are having limited resources in terms of agricultural lands. That is not getting enhanced in any way. Now, considering the last 5-year scenario of our own country, our population has stopped, or is it continuously increasing? It is increasing, right? Always. But agricultural land is not increasing. Nobody is saying that we are not actually going for urbanization. Every time we keep on hearing again urbanization, that means you chop away with agricultural lands. If I see Silicon City now, in 10 years before also, many open spaces, many agricultural lands were there. But now you go there just 5 kilometers away, apart from these institutions, and you'll be seeing in a concrete jungle. So that means you need to feed those people, right? Increasing population. So you need to enhance the productivity. And if you need to enhance the productivity, you need to add on your research and innovation so that the productivity enhanced even though the land is shrunk. So for those, what we are looking for in terms of the sensors, you talk about every aspects of sensor figures of merit: sensitivity, selectivity, limit of detection means how low you can detect, reliability, stability, performance, accuracy. Always you need more and more, dil mange more, more and more. We always need more. But do we pay for more? Now we become customer. We had been talking about R&D. Now, in the previous aspect, we had been innovator. We want more. We are dreaming more. Now we are customers. So you must give to receive. We keep on telling our kids also. During our lecture times in our classrooms also, we keep on telling this. But are we actually prepared to give to receive? We always need to get something. What if I have Mercedes? What if I have BMW? What if I have 3-storied building? What if I have this and that? But actually, are you going to pay for it? No. We do not. We say to our children, we must give to receive. But when it is implemented to us, no. Sharing is not caring. Okay. So for all aspects, we follow this. We do not want to give. We do not want to give anything. Okay. So, now talking about thinking these aspects in mind, that we are going for better product, always with having this sense that we are going to give you low cost. Because if you are going for commercialization, whatever biggest or largest or innovative, most innovative features you develop doesn't matter. At the end point of it, you have to sell. For sell, irrespective of you are coming from Great Britain or Northwestern University or Japan or China or Indore, whatever, the cost will matter. They will do comparative analysis and they will say, no, you go away. I do not need better product. So now you are looking at environmental sustainability. Few facts are there. Like IQAir, they measure the pollutants existing in countries. In 134 countries are there. If we talk about ranking of India in World Cup cricket, for example, world cricket, higher ranking is very good. But here we are ranking number 5 out of 134. Is it a good thing to have? No. Right? And many of these aspects are connected to many, not only like we keep on saying also another aspects, that we care for trees, we care for living organisms, we care for cattle, we care for sheep, we care for goat, everything we say, we care for birds. No. First and foremost, we care for ourselves. We have to live. So all these are connected to detrimental diseases, and as per World Health Organizations, roughly around 7 million premature deaths happen annually due to air pollution only. Now if you look at the countries which are actually not doing as compared to us, we should not be feeling proud about these statistics. South Asian countries and Central African countries were number 5. And major metropolitan cities in terms of the world suffering from this problem is These two are located in India, one from Meghalaya and Delhi, you all know. So are these a good features to have? No. So we need to go for something that should be alleviating these issues, and for those we need next generation sensors. Now you think about healthcare. Healthcare, many aspects, like you talk about what are the, in terms of the demographic population, number one disease in India. Which one is it? The population, the maximum people suffering from this. Diabetes, blood pressure, and then comes number 3 is this fellow. Kidney, CKD, chronic kidney diseases. And these are the aspects of the uric acid only. There are many factors, creatinine and other aspects of it, but uric acid, like you keep on going to your medical clinics, then you keep on getting your blood pricked out of your finger, basically like how we do in our household or homes by taking a blood sample and getting our glucose meter down. That is okay. But in this case, what the range is telling you, this range is okay, whatever is telling you is normal. The milligram amount of uric acid in blood, you go up and down, you are facing with these issues, detrimental. And if you are looking about some statistics, you can see roughly around 700 million people globally have been suffering, and out of those 700 million, 16% is remaining in India only, and it is keeping on increasing. If you think about only one aspect, one disease from CKD, that is the gout. That disrupts your system, and many a times when we go for the clinic for diagnose, that means pani sar ke upar ja chuka hai. Already your uric acid is high. So what you need, we are going to make a system, our startup and our innovative team at IIT Indore, all together we are making a system by which you can do point of care uric acid sensing at home, the way you can do blood sugar monitoring also at home. So what we need today is the point of care, fast and accurate, affordable, smart health monitoring system for kidney. So that is another aspect. And the third aspect which we talked about the agriculture. Land is squeezed down, but we need to increase the productivity. So many of us, we are hearing about, again, some dazzling words, precision farming, soil management system, applications of AI and IoT in terms of the agriculture. So all because of enhancing the productivity and reducing the usage of pesticide and fertilizers, so that eventually the annual household income of the farmer should be enhanced. So that's why the research and innovation should also go for these aspects. So these are the 3 aspects, 3 examples we'll be sharing with you how we are doing in terms of the basic point, quantum world and semiconductor manufacturing. Okay. Now, sensors, irrespective of any kind of sensors you make, what is a sensor? Like for example, our eye is a sensor, vision sensor. So if we need to make a sensor at lab, so you sense something, then you get the signal back to your R&D person in some way. What is that way? If it is a way of optical method, then it becomes optical sensor. If it is a way of some acoustic signal variations, then it is SAW, like surface acoustic wave sensor. If it is by a change of current value or resistance value, it becomes a resistance sensor. We are working in many aspects, our sensors are resistive. Why? Making a resistive sensor requires less amount of fund, requires less amount of manufacturing cost. Because whatever you remember, whatever we make, if we need to reach the mass, cost factor has to be minimized. So we work in the resistive aspects of it, but everything is related to the manufacturing part, semiconductor manufacturing. Now, in terms of the semiconductor manufacturing, we call about the life cycle. Life cycle is similar like a life cycle of a tree. You start with seeding, you go for different stages of it, sprouting, sapling, and in different terms of maturity of a tree, unless and until you get the fruit. The fruit in terms of our world is actually our products. Now, in the same case, what is the most important phase? Like if you think about this stage for tree, starting from the beginning up to the final one, what is the major stage of growing a tree from this chart? What do you think? First one, thank you, seeding. That is the major part. In the semiconductor aspect also, we call it hospital, in which we give birth to a child of material. And the material gives what? From our father. Mendeleev's periodic table, now you remember? Whatever thing we make, whatever thing we have over here in this room, in this building, outside world, everything comes from this particular gentleman's work. We have elemental presence, we mix and match, sometimes it becomes compound material. So we mix and match, and whatever we mix and match, we keep on doing in our hospital, means in our lab, in our industrial labs or in our academic lab. We give birth to our children. That is the material, that is the seed part of it. Once you are done, then you go for like what type of things you need. Whether you need bulk material, whether you need nano-sized material, whether you need something else. So this is the starting point. You think about your babies that you are going to produce this in the hospital. After that, what do you do? In semiconductor manufacturing, you need to now make or break basically some system. Now for making and breaking, now you think, you imagine, we have talked about here millimeter width. Now we talked about nanometer. Nanometer we even cannot see. Brownian motion, we have all heard about it. So we need to go to a room in which Brownian motion is nullified. Restricted amount of entry of dust particle which is of the order of micrometer. So ideally you cannot have dust particles. So you need what? Clean room. In our worlds, not from the domain of semiconductor manufacturing, clean room means this. Beautiful, a child sitting in the clean room. But in the, this is taken from Intel, so this is actually our clean room. Semiconductor manufacturing, but idealistically it is the same. We need a clean room. So in the clean room we go, and then we process, fabricate and do the device connections, make the device comes. Now if you think about nanometer, device will be of the order of nanometer. You will again not be able to see. After that you go for the system development, failure analysis, testing, calibration, those aspects of it. And after that comes who? After this step, mature tree means right now you are giving the fruits. So you are reaching the customer. They will be reaching at your products. And they will be saying, no, Apple iPhone 17, not good as compared to something as given by Samsung. So satisfaction, service, quality, those aspects come. So every year, night and day, you keep on thriving for something good, and at the end of it, somebody is coming and telling you, no, rubbish product you have made. So it is same like a daughter marriage. You know, you give your best to make all the 300, 500 people happy, and after that, nahi. पालक पनीर में पनीर कम था. So this will be the problem. So but this is a harsh world. Without reliability and throughput, large scale production in relation cannot happen. But this is actually the life cycle. This is everyone have to survive. But we should not forget, this is the main aspect of it. How many of you have seen the movie 300? So in this movie 300, whatever this person is saying, this is actually us. And this is the material growth. This is our child as material.
When the boy was born, they brought Spartans to use his strength small, puny, sickly, or misshapen, you will be discarded.
So if the quality of the material is grown at the seeding part of it, we throw it away. It is shown over there also. So then we go for quantum dimensional world and we grow this material like few slides that we have to give technical aspects. So this is one type of two-dimensional material or the quantum material in which we grow or we use atmospheric pressure chemical vapor deposition system in our lab. We make this material. What kind of material? It is molybdenum sulfide. Molybdenum sulfur comes from periodic table. So compound semiconductor material. So our students keep on working on different aspects of it unless and until these four persons are satisfied, controllability, scalability, uniformity, repeatability. Unless and until these are satisfied, you cannot even talk about commercialization or even cannot dream about commercializations from the material which you are trying to grow. So once that aspect is satisfied, then you go for the products, fabrication and then system development. But this is the very basic point of it. And that's why lots and lots of characterization, lots and lots of work go into the synthesis part or the growth part, the baby production part of it. Okay. So some aspects are given. These are different shapes of such quantum material. Molybdenum sulfide we talk about. We invest in the lab. First we design, then we try to actually see whether we are getting those things done experimentally or not. And then characterizations. Now once you are satisfied, so what kind of things or what kind of evidence we have seen in the previous slide? We have seen the evidence, how does it look like, how my baby is looking like. What do? We take a picture. The same thing, the previous one is also a pictures taken not by our mobile but microscope, same aspect. So baby looks good. Now you have to go to the doctor saying that my baby is good actually or not. So we need to do characterization. Doctors also need to do many different inspections, investigations on the baby to see that no, heart is okay, lungs okay. So here also we need to do lots and lots of study, optical, electrical, elemental, those things, and after that we are getting some inference from this study that these babies are good, ready for production or ready for actually realizing some very good device out of it. Okay. Then comes the laboratory part of it. You make a device. What kind of device you are looking to make? A nitric oxide or nitrogen oxide sensor. Now nitrogen oxide sensor, and while studying the sensitivity part of it, you need to go for different aspects. Like how reliable is it? Like different ppm levels of gases. There are different standards that we follow when we are trying to commercialize, for example, a gas sensor for the market. When you try to get a gas sensor for the market, then we need to follow Occupational Safety and Health Administration OSHA standard. And for those aspects, there is coinage of different ppm level at which your sensor is actually telling that this ppm value of nitrogen oxide gas is present and it is actually detecting. But it is possible in the environment like this, nitrogen oxide is there, carbon dioxide is there, hydrogen is there. So how do you do? So you need to have selectivity. So if you look at the selectivity graph, if your selectivity towards nitrogen oxide is very high as compared to others, so you have made a good sensor. So this is a good sensor with very good values of limit of detection and limit of quantification, means how low you can detect. So a good sensor as of now, okay, we call it part per billion or part per million level of nitrogen oxide sensor. And comparative analysis, so these aspects are all related to publication aspect. Remember, journal publication, a PhD of a student, something is affiliated to this. So performance metrics, we are doing really good. as compared to the standards existing in the literature. Okay. So few aspects I am telling you about the publication part of it and how, because the academic program should also go side by side in terms of the product production also. So this also should go on. Second aspect of it is uric acid sensing system, and this uric acid system, after lab stage study, what do? You need to do the uric acid sensing present in urine sample, blood sample, saliva sample. Can you do it in any lab? You cannot do. You need to have regulations authority and their approval to do it. Unless and until you do it, it will be unethical, and then obviously some prison of Madhya Pradesh will be waiting for you to take you in loyally. So what do you do that? To alleviate the problem? To alleviate the problem, we collaborate. Why we are collaborating? We are collaborating with All India Institute of Medical Sciences, Bhopal. So once we are happy with our artificially uric acid sample testing, then we go and check the performance of our sensor in the hospital, in the blood or serum samples, real samples. So they are actually the working with us in the product development phase of it. And here also those aspects lying the same: sensitivity, selectivity, repeatability, and earlier cases for gas sensing, it was carbon oxide, nitrogen oxide, sulfur oxide, and here you are seeing many aspects. The previous graph was showing you caffeine, adenine, ascorbic acid, glucose, those things by which you are studying the selectivity. How selective is your sensor? Okay. And then many aspects of the technical part of it, and many different phases also are going on at AIMS Bhopal in terms of how good is your sensor for real biological samples. The performance again is good, the selectivity, repeatability aspect is good. Then we have also developed some Android app, because whatever the measurement is done, because now we also think in parallel about the commercialization, go for the mass. So we have developed the app also along with it. Comparative analysis, we are doing good. This is the part which we have developed. Now, two examples I have shown you. You have developed in the lab, very beautiful, have major aspects inside the lab. Now you need to go to the market. You cannot take the entire lab to the market. But in order to move to the market, how will you be convincing your customers that you are the best? Because you are not Shah Rukh Khan, you cannot say I am the best, people will be agreeing. No. So basically you need to do what this gentleman is doing. You need to go to the market and sell your product. We keep on selling on this product. So while selling the product, basically your entire lab should be shrunk on top of your finger chip. So, or fingernail, we should say. So now what we need to do, we are just moving towards it. Make the lab on a chip. And the very aspect of it, you remember I told you about resistive sensor. All our sensor are resistive type. So you have big instruments, now you make the instrument on a PCB, printed circuit board, smaller platform. So for that you need to make a resistance readout circuit. And your resistance values change chemical sensor, or if you are going for a water sensor, or you are going for a gas sensor. But you need to sense the change in resistance with high precision. The precision and accuracy in terms of the industry standard, it is less than plus minus 5%. So first we did simulation. In the simulation, we have attained on a commercially available Proteus simulation tool. So less than even plus minus 1%, we are doing very good. Then we go for the breadboard implementation, then we went for the PCB implementations. In all aspects, we are maintaining the industry standard of less than plus minus 5%. We are happy. But as of now, our resistance changing is from some ohm value to some hundreds of kilo ohm. We want to go more. Some tweaking we did, And now we are reaching from kilo ohm, hundreds of kilo ohm to hundreds of mega ohm. We wanted more. We went from hundreds of mega ohm to now giga ohm. So our all aspects, whatever sensors we have made for the last 15 years, all resistance lies in this zone only. So we are happy. Now we do not need to venture out for another design to make another portable packaged platform for resistance readout circuit. So we term it as universal resistance readout circuit because it reads from ohm value to giga ohm values. We are happy. So we made this on, this is the first made, we should say, a PCB layout circuit for our system. We can sense the resistance value. Okay, very good. And then we keep on integrating on the system for different sensors. And this is the final product for the uric acid meter. We started with, you remember, Proteus simulation. We went for breadboard, then we made for the PCB, then we packaged it, we made the system. Once we made the system, we go for Android app development because whatever the features we are sensing, we should also have the app. And why the app, I'll discuss it later. Okay, so this is the in-house packaging of IoT-enabled uric acid sensor. And similar way, this is a portable sensor, which this is a short video you can see. This is a portable sensor to detect mercury ion present in water. And that is the similar way we have developed it. And because on this one, we got a new project to detect heavy element in industrial water. Again, sustainability of environment. And few aspects of heavy metal ions that goes into the agricultural lands and reduces the productivity. One of those heavy metal ions is mercury. So we have developed it and we are testing it, just the short video showing you. This is the calibrated sensor we have developed. So in terms of the agriculture, then again the product, and the product now we are reaching the mass. This is a product for B2C directly, business to customer. And this product we are preparing for farmers only, giving them two different suggestions. They might be having some agricultural land and they do not know what kind of crops to grow. We assess the micronutrients and the parameters that is present in the soil, and our system tells them which crop to grow for which type of season and to get the best productivity. And if you are having an agricultural land with crops, we will be telling you some tools or some parameters by which the productivity can be enhanced. Eventually our motto is what? To help farmers so that their annual household income should rise. Because for all of us staying in the entire country, our parents are the farmers. They are feeding us. They are our mother, they are our father. So we have to help our parents. So basically, this aspect of the work has been giving all of us working in our startup Quantec L2M and our group the maximum kind of satisfaction, because we are helping and reaching to the society, and we are doing this work and many outreach activities also. I'll be sharing some of the glimpses with you also, in which we are getting the maximum happiness in the entire world, we should say. Now, few more, agricultural, we should say, the portable system for major field applications we have developed. One is, we are terming it as Dharti, digital agriculture for real-time monitoring of soil health. This is the product which we have recently launched at IIT Indore, So this actually tells you real-time monitoring of 7 different parameters, temperature, soil moisture, nitrogen, phosphorus, potassium, pH value and electron conductivity of your soil on a 24/7 basis. So that you will be having some idea about what is the variations of these soil parameters with respect to the times of a day, with respect to days in a week, with respect to weeks in a month or different seasonal variations, so that you can get to give the educated information to farmers that probably their agricultural land does not need some specific kind of fertilizers, which probably, because when we talk to our farmers in terms of the purchase of fertilizer, in terms of the purchase of fungicide or pesticide, what we learned, they do not trust anyone else besides their whatever the predecessors have done. है ना, मेरे बाप दादा के ज़माने से ये बताते आ रहे हैं कि अगर राबी का खेती करना है, I need to use this, but maybe that is applicable in some agricultural land in UP, may not be holding true for Indore. So to make them go for example, Chennai Super King, leaving RCB is very, very difficult. So what you need to do? You cannot lose hope. You need to interact. We need to make some kind of brothership so that your voice, I'm saying, sir, but whatever is going into your ear and staying inside it, if it stays, some part of it, I'll be finding it very much beneficial. So now we are doing, our entire team has been doing, is involved in many aspects of it through different outreach activities in Gram Panchayat, in their, by going to their houses also, to making them know that probably this is not good for you. If you do not do this, you will be saving some money. It will come back to you. And we are doing this study and every aspects of it for free of them. Vasudha we have also developed. So the previous one, the product which is working with respect to internet connectivity. Now you think about 10 hectares of land. There is no internet. So those aspects if you need to do, you need to invent something for which long range communication should be work, like LoRa network should work. Even if you don't have the internet connectivity. So these aspect of it we put in now in our Dharti, and we made a new system, Vasudha, versatile. We are talking versatile means it works in Bluetooth, it works via wireless, it works via, there is no internet connection also. So for larger zone agricultural lands also, it will be giving us and telling us the seasonal variation or daily variations of NPK or the 7 parameters to us. Then in order to go inside of a 10 hectare land, it will be coming on top of the mobile app. So mobile app also was developed for the same. But making them understand, making them, they need it, that is also another aspect of it. Is it a part of our R&D and innovation? Yes. To make the mass aware, outreach, yes, it is a part of it. Who will do it? Again, I have to do it. We have to do it. Now, related to agriculture, in many cases, like many of us, how many of you know what is the major, or we should say number one crop of Madhya Pradesh? Soybean. But soybean, the productivity has gone down for the last 5 years. There are many different reasons for this. In the last few months also, you might be hearing and reading in the newspaper that now India has agreed to buy soybean from USA. Even the talking terms are going on. Because India, we can develop something and we can absorb also something. We have the market, we have everything. That is rightly what our PMO keep on stressing the same thing, Atmanirbharta. Because we can grow, we can absorb, we don't basically need anyone. So that's why USA needs us, because they need our market. But soybean productivity, what we learned for the last several years, they are facing several issues. Such issue is non-detecting the diseases that the plants are getting affected with. One such example is given in front of you, that leaves that comes on top of the soybean leaves. It is yellow mosaic virus. There are many other diseases also. I have the slide to show you. So for that also, when we do the soil nutrient study, we are also studying how it is related to the soybean disease and whether we can demarcate it quickly. Even if one leaf diagnoses the disease, we should get rid of it, so that it should not be cultivated across the huge land of the farmer. But again, what is the time for soybean growth? In a year. Which month the soybean is grown in a year? It starts from July, end in, we can say, first week or second week of October. So we studied this, and then we are preparing ourselves for the next time suggestions given to the farmers, so they should not do the mistake as they might have done this time. We are doing case studies. But this agricultural sensor activity is a huge activity in terms of the manpower involvement and in terms of satisfaction. My God, you will be enjoying it to the fullest. If being a Bengali, if I can communicate to localite indoor villagers, then also each and every person sitting in this room, you can. We all can. Unless and until you want to do something, you can do something. So satisfaction, yes, that is a guarantee from each one of us working in our Quantec L2M team. We are all happy. But at the end point of it, you will be getting something from them, yes. In the last panchayat event that we did at Simrol village, like 25 kilometers apart from this place, in which I have been trying my level best to bring your director to that village, and we keeping on thriving on the same thing, so that sir should come, and also if time permits, sir and madam should visit with us to actually one of such outreach activities. And it gives you satisfaction, it tells many things about how you can reach commoners and what aspects, even if tiniest or even if some higher aspects of it, you can try to improve in terms of their livelihood. So in these cases, what we are trying to develop a system that gives you early stage detection of diseases that happens on the leaves of soybean. One such information is given. But how to do it? So basically you need a robust system, because in terms of IT, or in terms of, we should say, database management, or in terms of big data communication, many things we know now. If you need to transmit something from, for example, one mobile, one IoT device to another, in many cases we need to do away with the redundancy. Sometimes you need to have, basically you need to have the information. But if you are trying to get the mass connected via your IoT portable network, so you remove the redundancy. For removing redundancy, we all know there are many aspects of it. Again, if you need to remove redundancy, again the solution goes to your lab, how you can remove the redundancy. And here, what kind of redundancy you are trying to remove? You are trying to remove the redundancy from the image of soybean leaves, for example, or the multimedia, that your drone is actually connected to a camera in which real time 1 kilobyte or maybe 1 megabyte or 1 gigabyte of video is given to you. Now if you need to do the processing part of it, and if you need to develop a time efficient and energy efficient system, you need to do away with the redundancy. Sometimes many information are redundant, we don't need it. So you generate an algorithm, and that algorithm based on our one of the technologies, we call it processing in memory in terms of one device. Right now I am talking about those things, but by which we can remove the redundancy so that your data remains with you. Ultimately what you need, make a product which becomes time efficient, that your drone goes across a soybean land and immediately it will be telling you, you have yellow mosaic here, you have yellow mosaic there, for example. But if you need to do such kind of cloud processing, then you need to go for smart preparation of your algorithm. So aspects of computer science is here, database management is here. So we developed a chip in the lab that does this on a hardware platform, and then we go and implement it on our Android platform. Again, not going into details. Some of the informations about how we do it, we implemented a technique called wavelet transform technique, but by which one can remove the data redundancy. And this data redundancy algorithm goes for preparations of or segregation of high frequency part of the image from low frequency part of the image, and different wavelet transform technique, be it a DWT, discrete wavelet transform, or wavelet packet transform, these are all technical words, and different words, they have their own systematic way to segregate from redundant information to actual information. So we implement those, and eventually, like here again I will be not going into details of it, CIE is involved in this case, like in the biological aspect of it, AIMS Bhopal was involved with us. CIE, do you know what is CIE Bhopal? Central Institute of Agriculture and Engineering in Bhopal. Because here we can take the image of a leaf, we can approximate this might be yellow mosaic, but who will be telling us? By touching your child, you might be seeing it, he or she might be suffering from fever, but you need to go and see a doctor to actually diagnose what actually he or she is suffering from. Here also the plant doctor need to go, plant pathologist we say. So CIE says, yes sir, this is actually yellow mosaic, or no, this is something else. So we go there, we make the database ready along with them. Okay. So then we do lots and lots of modeling and then make our performance parameter or neural network algorithm robust, so that we can make a tangible device ready again for the commoners. And I told you about one disease. These are all diseases that happen to a soybean leaf, and this does not happen on soybean leaves in India, across the world. So we need to segregate what kind of disease and what kind of disease is related to what kind of soil deficiency parameters. So this is a huge study that goes on. Okay. So major part of it, you can see our students sitting there, only they go and do this kind of field studies with them. You know, hectares and hectares of land. You need to identify, you need to collect the soils, and then you need to do and measure the performances. The performance in point, like on site, the performance taking the soil sample in the lab, the performance parameters also is determined about the soil sample goes to calibration purpose, because you cannot do the calibration. For the calibration, you need to go to the government affiliated labs, College of Agriculture in Indore, that is a government affiliated lab, whether the sensor that you have made giving you the data is actually the real data or a fake data. So then basically you do several aspects of measurements so that your calibration of your system is done. So Vikas, who is the CEO of Quantec LTM, sitting there, so this is him taking the soil samples to the lab and doing for calibrations. So after this, I'll be showing you a short video again, telling you the whole journey, starting from very first aspect of it to the final product development. And I'll be seeing how we actually moving forward by giving an example of our bio or the health sensor that we have mentioned. So once you're done with development of the products, in all aspects of the product development, the final part, reach the customers, reach the base, is the major aspect. And in many cases, when you need to do outreach activities, you need to do workshops, you need to convene many other aspects by which you reach the commoners. So in many aspects, we have reached villages, we have reached tribal places. This is another aspects in which we have been doing our outreach activities. Yesterday also on Sunday, we did a scientific social responsibility program in Netaji Subhash Chandra Bose Avasiya Balika Vidyalaya. So this is a, we should say, a girls' school that is supported by the government of Madhya Pradesh. And yesterday we went to the first most developed school in the state of Madhya Pradesh, that is in Choral, roughly around 37 kilometers from away. Like it is also 10 kilometers apart or away from Simrol. And there had been 200 girl students who are actually staying there, starting from class 6 to class 12 they can study. And these are the tribal girl students who are either orphans or they have a single parent. So generally every year we have a plan, our entire group, our entire family, that we need to earmark at least one activity. Like we are striving to do more, but I hope God will be providing us some support and His blessings so that we can do more. And you won't believe that when you go and interact with them, you spend time with them, the product that you have or you are making in their own language, you try to tell them how much enthusiasm, how much encouragement they are getting. Like yesterday, we keep on actually asking and every individual girl students from class 9, class 8 and how do you want to be? Majorly they are saying they want to be doctors, they want to be lawyer. They have expressed their feelings in terms of drawings also. Like we have taken pictures of their drawing and you won't believe, like you'll be imagining that there must be some kind of educated people who are telling them how to draw. No, there are no. They are devoid of any kind of basic systems, basic facilities, but yet the fire they have inside themselves, they are igniting, and they are and that kind of fire is actually telling them what to do. And the basic aspect, when I started this presentation, I told you about dream and imagination. Actually, at this age, I am learning from them how I should be dreaming and imagining. Because without the facilities, without anything, they are dreaming these aspects. So as of now, I should be thinking, I am not doing well, I should be doing more. So you will be making a better person once you do this kind of social activities and once you do this kind of outreach events. Because ultimately the products you will be taking for the mass. If you cannot educate the mass how the product is doing, what kind of benefits you will be getting at the root scale, then basically you are a failure, major failure. So those aspects we are doing in different outreach activities. We are doing also attending several conclave that happens in different parts of the country to actually make people aware what our products are and how beneficial is it if they use it and if it goes for the mass production. And of course, these awards, recognitions, they will follow. You follow your dream, you follow your imagination, you connect your heart and brain, you keep on doing whatever you need to do, and these things, accolades, prizes, awards, those aspects, that will follow. But showcasing your products is good. The showcasing to the grassroots level, the showcasing to the people also, that will be mattering to you strategically. So we have also showcased our products to various aspects to governments, and also in each and every aspect we have been getting accolades, but until and unless these products are commercialized in large scale, we will not stop. So with this, I will stop my presentation, and thanks to all of you. And you may ask me any question that you may have, and it will be very good to have some questions from you and to get to know each one present over here so that we can interact. And if you need to go for any kind of internship if it is a student or if you need to go for, we should say, research collaboration in any aspects if you want to do, we are always open. So these are the contact details that you are seeing on the screen. So you may drop an email to us. You can also reach us via our social network platform, LinkedIn or YouTube. So thank you so much.
Eyesight, but there are few who have that vision. So your session is reflecting that vision. Our eyesight saw this iPhone. Our eyesight doesn't able to see behind this how exactly this technology is developed. Similarly, one clip is missing. We have seen the movie Jurassic Park, the DNA extract from a mosquito, and then how exactly the planning is to commercialize it, that Jurassic Park, the planning. So whenever we talk about any technology, and here in your presentation, we are not able to know whether your qualification, you are an engineer or a medical science, because the human anatomy, the research that you people are doing. So that is something related to medical science. So this is what nowadays, as far as the collaborative work, so engineering technology with medical science, then marketing and commercializing of that particular product, whatever a prototype is to be developed, then to commercialize it, how to test it, how to take the confidence of a place where you conduct this particular study. So these things play an important role. These things play an important role. My question is, like, whatever the researches that you are doing, how you commercialize your products, what is strategy? Usually we have seen, like in US, the universities, they collaborated with the corporate houses, and through them they market those products. But in India we haven't seen such practices. So what exactly happened? How you people doing marketing of if once a product is ready for commercialization?
That's a very, very good question, and that's why I should be stressing on the same point that I have been keeping on mentioning, the vision of our PMO. In order to get your lab-based product to the market, you need to have a lively ecosystem. The ecosystem is not only you, it needs partnership from industry, it needs partnership from various strategic aspects of it. So now we have been seeing that kind of ecosystem has been growing on. If you talk about semiconductor manufacturing also, now many of you probably are aware that we have 2 hubs in the state of Gujarat. We have one hub for the domain of power semiconductor based on silicon carbide in Orissa. We have one hub taken by the state of Assam. We have 2 hubs taken by the state of Karnataka. And these are major manufacturing semiconductor hubs. And these major manufacturing semiconductor hubs are giving you, or will be giving you, probably starting from next year or so, many different aspects of the products for the mass. Actually, iPhone will be produced and manufactured here in India. 2 years or 3 years before also it was a dream. So now it will no longer be a dream because the ecosystem is made. And ecosystem, if you need to make it, that is the same point what Ster was asking me. Now it is there in India. So if you need to go and look for the venturing out of these products, different platforms. You need to get your product and showcase it like we had been doing. We had been doing for the B2B, we had been doing for the B2C. So you do outreach, the industries tie up, industries fund will be coming to you for the large scale production. So that is what we are hoping for, and I am sure now in the vision of Vikashit Bharat of our Prime Minister, Shri Narendra Modi ji, so by 2047 and before 2047 also, we are seeing major aspects of our startup products should be there in the market for the commoners to use.
Sir, as you said, the nanoparticles cannot be seen. So how the sensors, when you are growing them and then testing them also, how is it happening? Though I think I am not able to imagine it.
Like basically, how do you see, like whenever, for example, you are seeing the product, like for example, if I look at this product, this is a product, your heart of the product is lying inside it, which you cannot even see. So how do you experiment? Basically, when we see, how do you see? When you see an ocean as blue, like again going back to the school, how do you see? When I see the color of the wall is yellowish, how do we see? Because it is already the optical phenomena. You have a visible source of light, you get it reflected back from something, then you make an impression in your vision sensor, that is your eye. So you can imagine that this is yellow. Now when you try to see the dimension of the order of nanometer, can you use visible light? Because visible light is having a wavelength of, do you know the wavelength of visible light? It is roughly from 400 nanometer to 700 nanometer. Can we use this wavelength to see 1 nanometer? No. So we need to use something which is less than 1 nanometer. What is that? That is electron. Now electron can be produced in this atmosphere? No. We need to reduce down Brownian motion. So we need to do a vacuum chamber, reduce the vacuum level so that Brownian motion is gone. Then all of us remember how to produce X-ray, again going back to class 11. Like all these studies are related to our schoolhood times. How X-rays are produced. 2 electrodes are there, heavy voltage in a vacuum sealed tube. Then suddenly the impingement happens and lots of electrons are generated. Same way. Now you produce electron, make a device, we call it scanning electron microscope or tunneling electron microscope. You have your system, get inserted it, you take an image. Now you can see how it looks like. But phenomenon remains the same. Reflection, then you need to see the impression, and then you see how to look the system. If you need to sell it, your processor inserts iPhone 19 is of the order of nanometer. I am saying 19 because 17 we can all buy, 19 he is buying probably. So this processor is the order of nanometer, you cannot see, and none of us care also, but we need fast processing speed. If I want to see a movie or if I want to do some kind of video conferencing fast, the person or the thing that is responsible for it is actually taking nanometer dimension in his centimeter scale of device. So now here we are seeing centimeter scale of system, we should say. But who is doing the performance is our child who is born in the hospital, that we have seen. So that's why we cannot see. But that is the responsible factor for this performance. Absolutely. So in this aspect actually our lecture number 2 is scheduled on 11th of this month. There we will be talking about our business strategy in terms of the commercialization of these products. So I will be there. So that's why at the after thank you I should be entering also another slide, picture abhi baki hai. So that point of time we will be revealing and sharing with you some of our strategies we are just venturing out, in which we are actually collecting the feedback and some of our design strategies in which we are just placing it in front of the VCs of companies.
Good morning, sir. Sir, your two products are basically about targeting two very different set of customers. So I just wish to know what was your inspiration to switch to a different category? Like from healthcare, we are going towards a soil-based product. So how did you switch, or why did you switch to a different category?
So thank you for the question. So I actually mentioned about 3 products, not 2. One we are touching in terms of the health. One we are talking about the environmental sustainability, and one we are talking about agricultural domain. And all these domains, like how we are venturing out, we first look for the problems. You look for local problems. Earlier times we used to look at the West and see what kind of problems they are solving. Now many of us working in academia and industry will looking for the local problems, and all those local problems are the 3 products we are targeting. If you look at the sustainability development goal of United Nations, you will be seeing we are just touching upon 5 of those, and those 5 of those are actually inculcated with the demographic population that we have in our country. So we should say first we look for the problems that we have, like if we for example talk about our chronic kidney disease early monitoring system, yes, we are seeing 300 million annually from India, we are suffering from this. So we are just venturing out those domains in which we can make a mark and probably have a promising version of it if we are going for the solution for it. So that's how we go for it for our products.
What kind of challenges or problems do you see or did you face when it comes to convincing about this technology to the farmers?
Challenges is actually, if I give a similar example to you, making Mahendra Singh Dhoni convinced that you should leave CSK and join Kolkata Knight Riders. We could not convince during his tenure of IPL, even though he is belonging from eastern side of the India. So there was one person whom we could not convince. People might have tried, and here we are talking about maybe 40% of the population. So it will be taking a time, but we cannot lose hope. We will be keeping on trying these aspects. So making them know, we are not asking them to not to do something what their grandfathers or their fathers are telling them. We are just telling them that while doing that, if you do this, probably it will be saving you money. That one aspect, it will touch from a person sitting at the bottom of the pyramid to top of the pyramid. If you talk about saving of money, so you go through that aspect wise, that eventually your livelihood will be becoming better, because many case studies we have done, and in many aspects that farmers are selling their agricultural lands for building construction majorly because of the same thing, household income. Their kids are no longer interested for doing agriculture. They are going for urbanizations. I do not know why this study is not there, that we should go back to village. Rather than urbanization, we should be looking for ruralization, something like this one. I do not know why. Probably you are not looking. Because if all farmers sell their agricultural lands, what will happen to us? So That's how we are trying to convince them that if they do this, they'll be saving their money, household income will be enhanced, and eventually it will be better for their future generations to come. And to do this aspect of the work, that is what also I have mentioned in the hexagonal working methodology. We need each and every person sitting in this room and probably everywhere, irrespective of whichever domain you come from, irrespective of whichever degree programs you as a student are involved with. We need everyone. Because we are doing for the mass, we need some part of the mass also. Thank you. Yes, that is what when I presented the work on these two products, Vasudha and Dharti. So this we have implemented now in agricultural lands, and these are ready to go to the market products by which we are implementing technologies on IoT, the apps you are seeing also.
Sir, which technology is majorly applied in this particular project, sir?
Which technology also I have mentioned here in terms of the model development, wavelet transform techniques by which you can do image decompositions, and then neural network algorithms are there. When you are going for the AI application part of it. For IoT development, it is something else. Then sensor integration, because all these teams, they cooperate and then making an own car. Some is taking care of the tire part of it, some is taking care of the the part in which you are dealing away with the carbon related or sulfur related gases, those aspects. Some is taking care of the accelerator part of it, some is working on the sensor part of it, and eventually you make the entire car. So here also different teams are working in different aspects of the product.
Thank you, sir.
How do you look after the financial aspects while being an entrepreneur, and what are the places one has to start with when thinking of starting a tech-based startup?
That is another aspect in which I have mentioned to you that this particular aspect, that what are the funding opportunities available from private partners, from different public programs, from different government programs also. What opportunities are lying with us? We have earmarked many things. That's why I told you in part number 2 in our lecture we will be revealing those. So there are many opportunities available nowadays. If you want to make a startup, you please do it, because in the startup you have the enormous advantage that you do not need to pay for many things. You do not need to pay for your office. You do not need to pay for the manpower. You do not need to pay for the electricity or the water that probably many of us will be using for the product development. Those are taken care in many different ways by academia. Again, academia is funded by public or government in many aspects. So even if you cannot actually see the money, and also like many of us have this notion that unless and until we see the money, we think that no money is given to us. But if you aspect, like for example, IIT Indore is giving us, like we have established this startup in 2022. So 3 years. If we look at the space, manpower involvement, the electricity, the material cost, it will be lakhs of rupees. We cannot see, of course. So we think for startup there is no fund. But eventually we also got in 2 separate funds from Government of India, Startup India Grant, and there is an IONS program, that is a Section 8 company of IIT Bombay who have sanctioned us another chunk of fund to pursue these activities. But despite these 2, there are many different avenues in which you can actually pitch in your product and get funds. And that is the beauty of the startup, that an independent company, that many aspects in which you need continuous flow of fund, it will be obviously invisible to you, you cannot see, but you can eventually work with them and make the system. So there are opportunities, ample amount of opportunities, and many aspects we will be covering in our part 2 on 11th of December. So please attend those.
Sir, could you please highlight some of the new inventions related to the sensors related to the academics or managements?
No,
New
we are working in these different sensors only, which I have presented. In terms of management, no.
Like related to what we are having in digital and the sensors, new inventions related to any highlights?
Management sensors.
No, related to academics, like whatever used in this.
Academics related sensors. Like you are talking about curriculum on your app?
Yeah, related to that.
Okay, that does not become a sensor. That probably becomes database.
Any new inventions or the highlights related to this?
Like as of now, we are not, our group is not working on those aspects.
We can take one more question, last question.
For a very tech-oriented session, I have a question. Entrepreneurs often balance innovation with practical business concerns. Sir, how do you balance this in your project, in your work? Innovation with practical business concerns.
Practical business concerns I have mentioned, like for example, the agricultural sensor product that we have developed. One of the major challenges is to make the mass aware that actually you will be getting the benefits for your own good, for the good of your own home or the household. So that is one of the major aspects, or we can see the challenges that we have faced. So mass awareness is what we should be saying now. For that aspect is one of the main challenges that we have faced. But there is no shortcut to alleviate the challenge, so it will be keeping on trying, keeping on working with them. And then unless and until you have the friendship directly also, you cannot always send your troops to do the things for you. You basically need to come and sit with them and interact with them and get to know them. So then you will be having many answers lying in front of you.
Sir, you mentioned the word ruralization. So starting from problem, then to go to the idea, then to prototype, what structure or framework have you developed or the IIT have developed which we as a management teachers or future management entrepreneur can adopt that thing? I mean, why that phrase ruralization didn't come to us? What practices and all those things goes to reach to that kind of mindset?
Like we should be saying, for example, IIT Indore has started a program on data sciences with IIM Indore. So that is a very good master's program which are mainly oriented for the industry people, that they can come and they can pay some stipulated amount of fees and they can study, in which professors from technological institute and management institute, they teach many aspects of it, and many aspects of it are related to the products and hands-on experiences also. So that is a very good program. Always I think we have opened a seat of 40, and every time we are opening this and it is always full, and we have a pressure to enhance more number of seats for that. So we can see there are many aspects, like we have actually started a new venture with IIM Indore, and eventually we came out that this is a hugely successful venture. So why not, management institute and technical institute, they can come forward and they can make new programs for such kind of things also. It has good prospects.
Thank you so much, sir, for your knowledgeable and interactive session. We are all deeply enriched with your knowledgeable words. And now, I request Dr. Vivek Singh Kushwaha, sir, to formally propose the vote of thanks to Dr. Sheval Mukherjee, sir.
Thank you, Ritu. So whenever we talk about the startups or entrepreneurial journey or entrepreneur ventures, we can't limit ourselves with a particular aspect of knowledge. This is what in the beginning I said. Many a time it happens whenever even a student came, they are having a mindset, I'm planning to take a specialization of this or that. We always say, institute can't give you any specialization. If you work in an industry and work for say 5-10 years, you become a domain expert, that become your specialization. And many a time it happens that person is having a particular specialization but working in different domain, and after 5-10 years when we met, so they are working in a totally a different stream. The same applies with the faculty members. हम एक कुएं के मेढक बन के ना रह जाएं, हमको बाहर की दुनिया भी देखना ज़रूरी है. जब आप किसी भी सब्जेक्ट को डील करते हैं, तो उस सब्जेक्ट के इनसाइट के साथ में ये भी याद रखिए कि वो सब्जेक्ट्स की चेन या उसकी कड़ियाँ दूसरे सब्जेक्ट से भी जुड़ी हुई हैं. And you have a knowledge of that particular area, then only you are able to do justice with your own subject. That's the objective basically. If any startup is coming up and if they expect any solution from your side, how you are going to provide that solution if you don't know anything about it? Especially in present scenario, we can't limit ourselves with a particular one single knowledge. So obviously we have to work and we have to enhance our skills, enhance our knowledge in different domains. Then only we are able to give a solution to other areas. And the objective of this is, if we plan it out our curriculum and if we incorporate an entrepreneurial journeys or entrepreneurial quality in particular subject, then how we are going to incorporate? What sort of exercise we should take? Here in this session, we have seen a different products. In fact, the finished product, ready to market product, are different sensors. Last time when I purchased a car, they said, sir, in this car, you are having total 12 cameras, so many sensors. In the phone are 3 cameras. What is the utility of these many cameras? What this camera is doing? But whenever we are driving and we saw many a time that car applied brake automatically. I'm not applying. Whenever I take a reverse, it applied brake automatically. Many a time on road, I'm not able to see someone is coming from side and coming in front of me. So car applied brake. So these are the sensors. These are the sensors. And how fast that algorithm is working, within a fraction of second, we are not able to decide, but that vehicle is taking those decisions. Now, if you are working in that automobile company, what type of products you have to deal with? You are a management graduate, a commerce graduate, or whatever your discipline is, but you have to deal with these products. if you do not have a thorough understanding of a particular product, how you are going to deal. Similarly, in classroom, the example that you have to take, the type of example related to science, then medical science, or automobile, or any other areas, how you are going to deal or take those examples if you doesn't know the depth of that particular product. That's why these insights play an important role. These are the skill set that we have to enhance. Sir, we are really very thankful in part one of your session, and I'm sure about it as far as the next session is concerned. Again, a very insightful, a very knowledgeable session, and the type of research that you are doing. These are the things that we are able to know that these researches are going on. So later on, what type of products is supposed to come in market, what type of market is supposed to be. So this enhance our knowledge too. I'm really very thankful, sir, for your session. Thanks a lot, sir.
Thank you very much, sir. I once again request you and Professor Utpal Sen, sir, to please present a token of remembrance to our esteemed resource person, Dr. Shebil Mukherjee, sir.
It was a sunrise industry in 1981. Even today it is a sunrise industry. And I am happy that now academia has understood, and the way sir has said, India has understood that whatever research is to be done, it has to be done what the common man needs. This has entered the... Should I keep the mic on? So sir is working in three areas, and all three are very much needed by the country. And we also tried to do so many things in our journey of electronics. But today the fabrication, the way it is taking over, it is really a dream come true. The fabrication part was difficult. That's why I asked a question, how we are doing it. We were having only semiconductor complex. Some engineers are here. It was burned down. So now India, in many of the places, they are working on it. And I am sure, sir, with your leadership, India will get some beautiful products which will be commercialized. Our IBMR team person is also available for the commercialization. Mrs. Mukherjee, you please take care of the commercialization part. Okay, thank you, sir. Thank you.